you guys. It is test time. So I hope you guys take this serious, especially this one. After your two practicals, I do expect that you guys earn a good grade on your exam, especially if I'm gonna be reviewing two problems with you. So, anyways, this is the first problem. Um, so how many moles of nitrogen oxide would be formed with 24 grams of NH3 or ammonia, basically? Okay, and this is your equation. So we are going from grams to moles, right? Because we're going to start with your given and then end up with the unknown, which is moles of nitrogen oxide. So grams to moles, right? Grams of given and moles of unknown, right? Because your moles is unknown. Okay, so let's go ahead and get started. And we're going to start with Gummer. So Gummer would be the G would be for your given, which is 24 grams of NH3. Okay, NH3. Then it is your unknown. Your unknown would be moles of nitrogen oxide. So it would be moles of NO. Okay, and then the MM would be molar mass. So whoever has molar mass in here, then that's the element or compound that you need to get the molar mass from. So the grams that you see here, that is going to be the molar mass. That's the one you need to take the molar mass. So it will be NH3. Okay, so NH3, so let's go ahead and look at the atoms. So nitrogen has only one atom and hydrogen has three. So each atom of each one has a certain mass or grams in the periodic table. So nitrogen will be 14.007. And then hydrogen, which we've done several times, would be 1.008. Now, I did put the periodic table link next to the problem, so just in case for the other problems that you need to solve, you could go ahead and just click on that. So that's 1 times 14.007 equals the same. And then this one, we would just multiply with a calculator. And I did put also the calculator in there, calculator in your problem. And that will be 3.024. Then you add each one because we wanted the molar mass of the entire thing. Okay, so so we add that with 14.007, and that would equal to 17.031. Now let's go ahead and do the last part, mole ratio. The mole ratio is based on the number of unknown and a number of the given. Okay, it's number and unknown. Number and given. So what do I mean by number? The number will be basically the from the equation. So and the unknown will be from the given and from here, from this, from the U and the G. Okay, so let's start by saying that mole ratio is always going to be mole over mole, no matter what. The unknown of the mole ratio will be NO. So it would be nitrogen oxide. Okay, and then the given is your ammonia, which is NH3. Okay, and then the number, I will get it from the equation. So you always do the U and the G first. Make sure you do those so you can know which one you're going to get. So really all you need is really these two, NO and then NH3. You really don't need the rest. You really don't. So this is NO, so that means it's a 4. This is NH3, so that's also a 4. Okay, so now we're ready to set it up. Since we have to have space for the given, and then molar mass and mole ratio, so that means we need 3 spots. Okay, so you always, I don't know how many times I have to tell you this, always start with your given. Okay, so that will go first, and we are no longer gonna need this. That's it. Okay, the next one. Now, keep in mind that unknown is just lost. So don't worry about unknown. Really, you need to know where you're going to put your molar mass and your mole ratio. So now, since this is grams, right? This is grams of NH3. Then this one has to be grams of NH3. Okay, it has to be the same. The only one that is grams and NH3 is your molar mass. Okay, so remember that this is grams of NH3. So that is grams. So that means you're going to go ahead and put this number in here, 17.031 grams of NH3, which is true. This is a gram. This is a molar mass. Okay, so that means molar mass is going to be here. Now remember that molar mass will always equal to 1 mole. So on the top will be 1 mole. Okay, the next thing, you're gonna do is, and by the way, that's 1 mole of NH3, right? So now, if this is mole of NH3, that means this is also mole of NH3. So it's across every corner. It has to be the same. It has to be the same. And by the way, these cancel each other out. Okay, and this will in a little bit. So who has mole of NH3 on the bottom? Well, it's your mole ratio. Anyways, we already used our given. We already used our molar mass. The unknown will go last, so we know that. But really, we know that this is gonna be mole ratio. So really, you just have to put this in here. So it would be 4 moles of NO on the top, and then 4 moles of NH3. Okay, so now one way to check your answer, just to be sure, is I give you these. So this is grams of my given, right? Because that's grams and then given. 1 mole is on the top, and that's given because it's NH3. Molar mass of the given, because NH3 is the grams and NH3, right? And then the next one's the moles of unknown. So moles of unknown is moles of NO. So it is 4 moles of NO. And this is the mole ratio. So it's right here anyways. And then the moles of given will be NH3, and then it will be moles, right? So anyways, again, this whole thing is mole ratio. So really, you just have to put this whole thing just the way it looks in here. Okay, so we are ready to calculate. Keep in mind that you're going to multiply the top, multiply the bottom, and then you're going to divide each one. So I suggest 24 times 1 times 4. So let's go ahead and put it in there. 24 times 1 times 4. Again, you're multiplying the top. Okay, that would be 96. And then the bottom, 17.031 times 4 equals 68.124. So I'm going to clear it because 96 is on the top, so you're going to put that one first in your calculator. So 96 divided by 68.124 equals 1.41. Now, since there's a 9 in here, I just put a 1 in here, so I could round it. So it would be 1.41. Now these canceled, so the only thing that's left over is really the moles of NO, so which is moles of NO. So that is your answer.